Hi, welcome to Voice of Prophecy. Today we are diving deep into one of the most exciting frontiers of science, robotics and space exploration. The story of human curiosity has always been about pushing boundaries, stepping beyond what we know and exploring the unknown. From ancient sailors navigating by the stars to the first rockets piercing the sky, humanity has been driven by a desire to understand the universe. But in the modern era, that desire has been amplified by technology, especially robotics, which allows us to explore worlds far beyond our physical reach. Imagine standing on the surface of Mars or peering at the icy plains of Europa, a moon of Jupiter. The environment is harsh, the temperatures extreme, and the distance from Earth unimaginably vast. Sending humans there is possible but risky. This is where robots become our eyes, hands, and even our curiosity in space. Robotics allows us to extend our presence into regions that are too dangerous, too distant, or too hostile for humans. One of the earliest examples of robotic exploration in space began with probes and satellites. In the 1960s, robotic spacecraft were sent to the Moon, Venus, and Mars to capture images, measure atmospheric conditions, and collect data about planetary surfaces. These machines, although primitive by today's standards, laid the groundwork for what we now consider modern space robotics. They taught us something fundamental: robots can survive where humans cannot, and they can gather invaluable scientific data that shapes our understanding of the universe. The Mars rovers represent the pinnacle of robotic space exploration so far. Spirit and Opportunity were the first rovers to traverse the Martian surface for extended periods. They explored valleys, craters, and plains, analyzing rocks and soil, searching for evidence of water. Opportunity, for instance, lasted almost 15 years, far beyond its planned mission of just 90 days. It revealed that Mars once had conditions suitable for life, a discovery that changed our understanding of the red planet forever. Following them, the Curiosity rover arrived in 2012 with a suite of instruments capable of analyzing rocks and soil in unprecedented detail. Its mission was to determine whether Mars ever had an environment capable of supporting microbial life. Curiosity's discoveries confirmed that ancient Mars had rivers, lakes, and even the chemical building blocks necessary for life. The rover's success highlighted a critical lesson. Robotics not only allows exploration, but also enables scientific investigation in environments completely inaccessible to humans. In 2021, NASA's Perseverance rover joined the exploration of Mars, carrying advanced instruments to search for signs of ancient life. It also carried the Ingenuity helicopter, the first powered flight on another planet. This small drone demonstrated the potential of aerial robotics in extraterrestrial environments, scouting terrain, planning paths for rovers, and capturing perspectives impossible from the ground. This combination of ground and aerial robotics is just the beginning of how machines are revolutionizing space exploration. But Mars is just one example. Robotics is not limited to planetary rovers. On the International Space Station, robotic systems such as Canadarm2 perform tasks critical to the survival and efficiency of astronauts. Canadarm2 can capture cargo ships, repair satellites, and assist astronauts during spacewalks. The use of robotics on the ISS illustrates how machines extend human capabilities in orbit, performing delicate and precise operations while reducing the risk to human life. Looking beyond Earth and Mars, scientists are now developing robots designed for moons and asteroids. Europa, a moon of Jupiter, has a thick ice crust and a vast ocean beneath it. Robots capable of drilling through ice and exploring subsurface oceans could one day detect signs of extraterrestrial life. Similarly, Titan, Saturn's largest moon, has a dense atmosphere and liquid methane lakes. Robotic drones and submersibles are being designed to fly through Titan's skies and sail its lakes, gathering data that could redefine our understanding of planetary habitability. The evolution of robotics in space is closely tied to artificial intelligence. Future robots will not only follow commands, but also make decisions independently, navigating unknown terrains, avoiding hazards, and optimizing scientific investigations. Autonomous robotics is key to deep space missions where communication delays with Earth make real-time control impossible. AI-driven robots can analyze soil, detect life signs, map terrain, and even repair themselves, all without direct human supervision. Robotics also plays a role in preparing for human colonization of space. Before sending astronauts to Mars or establishing lunar bases, robots can build habitats, mine resources, and test life support systems. They act as scouts, engineers, and builders, ensuring that humans will have safer conditions upon arrival. By performing dangerous tasks first, robots protect human life and accelerate the pace of space exploration. The significance of robotics in space is not only scientific, but also technological. Advances developed for space exploration often trickle down to everyday life. Robotic arms, AI navigation, autonomous drones, and advanced sensors have applications in medicine, agriculture, disaster response, and industrial automation. Space robotics drives innovation, creating technologies that benefit humanity both on and off Earth. Imagine a future where robotic missions have mapped the surface of every planet, explored every moon, and analyzed countless asteroids. Imagine autonomous laboratories operating on Mars, Europa, and Titan, sending daily updates to Earth. Imagine astronauts arriving at habitats built and tested entirely by robotic systems, equipped with knowledge and infrastructure to survive and thrive. This future is not science fiction. It is the trajectory we are on thanks to robotics. However, the journey is not without challenges. Space is unforgiving. Radiation, extreme temperatures, low gravity, and micrometeoroids can all damage delicate machinery. Engineers must design robots that are resilient, energy efficient, and capable of autonomous problem solving. Each mission pushes the limits of engineering, AI, and materials science, teaching us not only about space, but also about our own technological capabilities. The fusion of robotics and space exploration symbolizes humanity's desire to transcend limitations. We are no longer confined by our physical presence on Earth. Machines become extensions of our senses and intellect, enabling us to explore places we could only dream of. Every rover that rolls across a distant planet, every robotic arm that repairs a satellite, every drone that soars over alien landscapes represents human ingenuity, courage, and curiosity. In conclusion, robotics in space exploration is more than technology. It is a testament to human ambition. It combines engineering, computer science, physics, and biology to answer some of the most profound questions. Are we alone in the universe? What are the limits of life? How far can humanity go? As we continue to innovate, the line between human and machine will blur, and together they will open doors to the stars, pushing humanity further than ever before. The universe is vast, mysterious, and full of challenges, but with robotics as our ally, we are no longer passive observers. We are explorers, pioneers, and seekers of knowledge, reaching into the cosmos with intelligence, creativity, and an unyielding drive to understand the unknown. Robotics and space exploration are not just a field of science. They are the story of human potential written across the stars. As we look to the stars, robotics is no longer just a tool. It is the bridge that connects human ambition with the vast unknown. Every rover that traverses a distant planet, every robotic arm that repairs a satellite, every autonomous drone that soars above alien landscapes reminds us of one undeniable truth: humanity's curiosity knows no bounds. Through robotics, we extend our senses, our intellect, and our presence across the universe. We prepare for challenges we cannot yet fully imagine and uncover mysteries that were once beyond our reach. The future of space exploration is not about what humans alone can achieve, but about what humans and machines together can accomplish. In this partnership of innovation and exploration, the impossible becomes possible. The universe, vast and mysterious, is no longer an untouchable frontier. It is a canvas for human ingenuity, powered by the machines we create. Robotics is our legacy in the stars, our eyes on distant worlds, and our hope for understanding what lies beyond. As we continue to innovate, explore, and dream, one thing is certain. The journey of discovery has only just begun, and the cosmos is waiting for humanity's next bold step.